Hey guys, tonight we follow one of the quietest wonders in the sky, a moment when the bright afternoon begins to soften and the world seems to pause without fully knowing why. You can picture it already. A warm day, a familiar patch of ground, a sky that looks perfectly ordinary until something subtle begins to change in the light. Before you get cozy, take a moment to like the video and subscribe, but only if you genuinely enjoy spending time here with me. And if you feel like it, post your location and local time in the comments, because there is something strangely comforting about imagining all of us listening from different rooms, different cities, different little corners of the same turning Earth. Let the world slow down for a moment. Let the fan murmur softly nearby, and let's slip into tonight's journey together. An eclipse begins so gently that for a while you could almost miss it. There is no dramatic curtain dropping across the sky, no giant cosmic gong. The universe, as usual, prefers understatement. The first change is often in the sunlight itself. It starts to feel thinner, as if the day has taken one quiet step backward. Shadows lose a little of their confidence. The brightness remains, but it no longer lands on the world in quite the same way. That softness comes from a simple and beautiful arrangement. A solar eclipse happens when the moon moves between Earth and the sun, and for a brief time it blocks part of the sun's light from reaching you. That sentence sounds almost too neat for something so hauntingly lovely, but the science really is that clean. The moon is always traveling around Earth. Earth is always traveling around the sun. And every so often the geometry lines up closely enough to create this passing dimness. It is a matter of motion, distance, and timing, all carried out with such patience that the whole thing feels less like an event and more like a breath. The moon, by the way, is not sneaking around with villain energy. It is moving at its usual orbital speed, doing what it always does. It just happens that from your viewpoint on Earth, it drifts across the face of the sun in one of the most graceful visual coincidences in nature. The moon is much smaller than the sun, of course, wildly smaller, but it is also much closer to you. That is why the two can appear almost the same size in the sky, which is rude, honestly, because it sounds made up. But it is true, and it is one of the reasons eclipses feel so strangely perfect. Long before the sun is fully covered, the world begins to notice. You notice. The light takes on a silvery quality that is hard to describe until you have seen it. It does not look exactly like sunset, because sunset comes with warm gold and orange and a clear sense of direction. Eclipse light is different. It feels cooler, flatter, and more delicate, as if the day has been filtered through very fine paper. Familiar things start to look slightly unfamiliar. A road, a garden wall, the leaves of a tree, your own hands. Everything is still there, only quieter. Part of the reason this feels so uncanny is that your brain is deeply used to sunlight behaving in consistent ways. Daylight is one of the oldest patterns in your life. It brightens gradually in the morning, climbs, warms, leans, and fades. During an eclipse, that pattern is interrupted. Very politely, but still interrupted. Your senses pick up on that break in rhythm before your thoughts fully explain it. That is one reason people often describe eclipses as emotional even when they are trying to be very scientific about it. The science is exact. The feeling is harder to file away. As more of the sun is covered, the air can begin to cool. Not by some magical amount, not in a movie-style plunge, but enough to be noticed. The sun is the source of almost all the warmth you feel outdoors during the day, so when part of its light is blocked, the heating of the ground eases a little. The change depends on the eclipse, the weather, and where you are, but the principle is simple. Less sunlight reaches the surface. The surface gives less warmth back to the air. The afternoon loosens its grip. And because Earth is such a responsive little world, other things can shift as well. Breezes may alter. Birds sometimes grow quieter. Insects can behave as if evening has arrived early. These are not mystical reactions. They are practical ones. Many living things rely on light as a clock. When the light changes in an unfamiliar way, they answer in the only language they know, which is behavior. And that can make an eclipse feel even more intimate because it is not only something you watch. It is something the whole environment participates in. One of the loveliest details appears under trees. If sunlight is filtering through small gaps between leaves during a partial solar eclipse, those gaps can act like tiny projectors. Instead of making their usual dappled circles of light on the ground, they create countless little crescent suns. You glance down and see the eclipse repeated over and over across pavement, grass, or stone, as if the tree has quietly become an astronomer. It is one of those details that feels almost too charming for physics, and yet physics is exactly what it is. Light travels in straight lines. Small openings form images. The sky writes itself on the ground. There is another calm truth hidden inside all of this. Eclipses are not rare in the universe in the broad sense. Shadows crossing worlds happen all the time. Moons pass in front of stars. Planets cast darkness on their companions. What is rare is the version you get to experience here, on this particular planet, under this particular sky, with a moon that sits at just the right distance to cover the sun so beautifully. You live in a place where orbital mechanics occasionally become art. Keep that image nearby, because it matters more the deeper we go. And yet even at this early stage, before the deeper darkness of a total eclipse, there is already something profoundly relaxing about the whole arrangement. Nothing in it is hurried. The moon does not lunge. The sun does not flare in protest. Earth keeps turning. The shadow moves. Light thins. Temperature softens. Birds reconsider their schedule. You stand inside a pattern so old that human history barely brushes its surface. Ancient people watched this same geometry play out with different words and different fears and different songs, but under the same sky rules. The same moon crossed. The same sun waited behind it. The same soft confusion reached the ground. There is comfort in that, a deep one, the kind that does not need to announce itself. An eclipse reminds you that the universe can create wonder without violence, grandeur without noise. It can take one bright, ordinary day and, through nothing more than alignment, turn it into a memory that feels larger than language. And the further you look into it, the more the calmness grows. Because this is only the beginning, only the first dimming, only the first quiet clue that light itself has layers, that shadows can have structure, and that the sky is full of slow arrangements waiting to be noticed. Soon, that strange change in daylight will become even more delicate and more revealing. The shadows themselves will begin to behave in ways that feel almost playful, almost secretive. Edges will sharpen, crescents will appear, and the world will show you that light is never as simple as it pretends to be at noon. Remember this first softness, this feeling that the day is becoming gentler without quite becoming dark, because it is the doorway to everything that follows. That gentler daylight keeps deepening almost without announcement, and the reason is wonderfully simple. The moon is continuing its slow crossing in front of the sun, moving along an orbit so steady that it can feel less like motion and more like intention. You are watching a shadow event, yes, but you are also watching a timing event, a distance event, a patience event. Three bodies are moving through space exactly as they always do, and for a little while their paths overlap in a way that gives you this soft astonishment. The moon circles Earth about once every month, though the exact timing depends on which kind of month you mean, because astronomy enjoys being elegant and slightly inconvenient at the same time. From one new moon to the next takes about 29.5 days. That is the rhythm people have noticed for thousands of years. But a solar eclipse does not happen at every new moon, even though that is the phase when the moon sits roughly between Earth and the sun. Most months, the moon passes a little above or a little below the sun from your point of view, and the sky remains perfectly ordinary. That happens because the moon's orbit is tilted relative to Earth's orbit around the sun. Not by much, just a little over 5 degrees, but in celestial terms that is enough to keep the shadows from lining up most of the time. It is one of those modest little angles that changes everything. A small tilt is the difference between a routine new moon and an afternoon that feels enchanted. So when an eclipse does happen, you are seeing more than a monthly pattern. You are seeing a monthly pattern intersect with a rarer line of alignment. The moon has reached one of the places where its path crosses the plane of Earth's orbit, and the geometry has agreed to behave beautifully. Those crossing points are called nodes, which is a calm and tidy word for something so dramatic in effect. When the sun is close to one of those nodes at the same time the moon is new, the chance of a solar eclipse arrives. That does not mean every eclipse will look the same from every place. The shadow the moon casts is not spread evenly over the whole planet like a blanket. It is more selective than that. The darkest central part of the shadow traces a narrow path across Earth's surface, while a broader, lighter shadow covers a much wider region where the sun is only partly blocked. This is why some people experience totality, where the sun can be completely covered, while many others see only a partial eclipse. You could travel just a few hundred kilometers and have a completely different memory of the same event. One town stands in a darkness soft enough to reveal stars. Another gets a beautiful crescent sun and a silvery afternoon. The cosmos is generous, but also very precise about seating arrangements. The shadow itself moves quickly across Earth, much faster than any cloud shadow you are used to seeing. That speed depends on the geometry of the eclipse and where the shadow falls on the curved surface of the planet, but it can sweep across the ground at astonishing rates. Even so, the experience does not feel fast when you are inside it. It feels slow because the changes in light arrive in stages. Your senses receive the event as a gradual transformation. A little dimmer, a little cooler, a little stranger. It unfolds like music written for long notes. And there is another lovely subtlety here. The moon does not always cover the sun in exactly the same way, because the moon's orbit around Earth is not a perfect circle. Sometimes it is a little closer to Earth, and sometimes a little farther away. That means its apparent size in the sky changes slightly. Earth's orbit around the sun is not a perfect circle either, so the sun's apparent size changes a little too, though more gently. When the moon is closer and looks slightly larger, it can cover the sun completely in a total solar eclipse. When it is farther away and looks slightly smaller, it may leave a bright ring of sunlight around the edge. That is an annular eclipse, and it has its own quiet magic, as if the sky has placed a ring of fire in exactly the wrong part of the afternoon. That changing distance is such a small detail to hear about in a sentence, but it means the difference between one of the most haunting sights in nature and one of the most delicate. Keep that image nearby, because it says something important about the universe. Tiny differences in distance can reshape the whole mood of the sky. Even during a partial eclipse, the moon's progress has a kind of grace that is easy to underestimate. You are not seeing a bite taken out of the sun by some invisible creature from myth, though honestly that image has excellent dramatic instincts. You are seeing the crisp edge of the moon itself, a real world, round and silent, drawing across the bright disk of the sun. The curved dark shape is the outline of a place. A dry, cratered, airless place, drifting nearly 384,000 kilometers away on average, yet able to reach into your daylight and alter it. That is one of the most relaxing facts about eclipses, strangely enough. They make distance feel intimate. The moon is not close in any ordinary sense. It is far beyond airplanes, mountains, weather, and the whole chattering layer of daily life. and still it can quietly place its shape across the sun with such accuracy that your backyard, your street, your nearby trees, your skin, your eyes, and the very feel of the air begin to change. You live in a system where very distant things remain tenderly connected. There is also something comforting in how predictable eclipses are. They may feel mystical when you are standing under one, but they are not chaotic. Astronomers can calculate them far in advance, down to remarkable detail. They can tell where the shadow will touch, how long it will last, and how the alignment will unfold. That certainty does not make eclipses less beautiful. If anything, it makes them more so. The event is not random. It is woven into the clockwork of motion. You are watching certainty become wonder. Long ago, that predictability was much harder to see, because the sky looked grander and less explainable when the mechanisms behind it were still hidden. Yet even then, people noticed patterns. They tracked cycles, recorded events, and slowly learned that eclipses were not moods of the heavens but recurring alignments. One of the most famous eclipse cycles is the Saros, a period of about 18 years after which the Sun, Earth, and Moon return to nearly the same relative geometry. Not exactly the same, because the universe likes subtle variation, but close enough that similar eclipses repeat. There is something deeply soothing in the existence of a cycle like that. It means shadows have memory. And while the moon continues its unhurried crossing, you can feel how much of eclipse beauty comes from restraint. The sun is still mostly there. The day has not vanished. The transformation stays incomplete for a long while, and that incompleteness is part of the fascination. Your mind leans closer because the sky is offering a change in careful increments. It does not overwhelm you. It invites you. Soon, the invitation becomes even more delicate. The light on the ground begins to reveal its own structure. Tree shadows stop behaving like ordinary tree shadows. Tiny openings start sketching crescents. Brightness becomes something you can almost study with your hands. Remember that the moon's crossing is not only changing how much light reaches you, it is changing the shape of the light itself, and that quiet little detail is where the sky becomes truly strange. The shape of the light itself begins to matter more and more, and that is where an eclipse quietly turns from beautiful into deeply peculiar. You are no longer only noticing that the world is dimmer. You are noticing that sunlight has changed character. It starts acting like something with edges, something with geometry, something you can almost catch in the palm of your hand if you are patient enough and standing in the right place. On an ordinary bright day, the sun looks round in the sky, and because it is a wide glowing disk rather than a single sharp point, the shadows around you usually have soft borders. A tree shadow, a hand shadow, the shadow under a chair, all of them fade a little at the edges. Light spills around objects in a generous way. The world is lit by a broad source, and broad sources make softer shadows. Your eyes are so used to that arrangement that you barely think about it. During a solar eclipse, the visible part of the sun is no longer a full round disk. It becomes a crescent, or a thinner crescent, or a narrow sliver, depending on how far the moon has moved across it. That means the source of the light has changed shape, and the shadows on the ground begin to carry that information. This is one of the calmest and most delightful facts in astronomy. The light is not only arriving, it is reporting. You can see this most clearly beneath trees. Those small gaps between leaves, the tiny spaces that usually just scatter ordinary daylight, begin to work like pinhole cameras. Each gap allows rays of sunlight through in a narrow bundle, and because light travels in straight lines, the patch of brightness formed on the ground takes on the shape of the sun at that moment. During an eclipse, that shape is a crescent. So the pavement, the grass, a wall, or even your shirt can fill with hundreds of miniature suns, all matching the one in the sky. It feels a little ridiculous the first time you notice it. You look down expecting harmless leaf shadow confetti, and instead the tree has covered the ground in astronomy. Little crescents everywhere, like the afternoon has been stamped with tiny silver smiles. The beauty of it is that nothing extra had to be added. The tree was already there. The sunlight was already there. The geometry simply became visible. This works with almost any small opening, not just leaves. A colander can do it. Crossed fingers can do it. A little hole in a piece of paper can do it. Even a gap between the edges of two objects can project the sun's changing shape. You do not need expensive equipment to meet this part of the eclipse. The world is full of accidental instruments. That is one of the sweetest things about the science here. The explanation is precise, but the experience feels generous. Nature makes the demonstration easy to join. As the sun narrows, shadows can also start looking sharper. That happens because the light source is effectively becoming smaller in one dimension. There is less broad spill, less overlap, less gentle wrapping around edges. The penumbra, the softer outer part of a shadow, can tighten. Everyday objects begin to cast shadows that look slightly cleaner, slightly stranger, as if someone quietly adjusted the focus of the afternoon. You may not even know what feels different at first. You just sense that the world has become more exact. This sharpening is subtle, and it does not always announce itself dramatically, but once you notice it, the feeling is unforgettable. It is like the day has become more careful. The bright parts are more deliberate. The dark parts are more composed. You are seeing how much the quality of light depends on the size and shape of its source, which sounds like a sentence from a physics classroom until the sky performs it so gracefully that it feels almost tender. Colors can begin to shift too, though this is more about the way your eyes and the atmosphere share the work of seeing than about the sun itself changing color. Eclipse light often feels cooler and less golden than late afternoon light. Part of that impression comes from contrast. Part comes from the fact that the overall brightness is dropping in a way that your visual system does not encounter very often in daytime. The world can seem flatter and more silvery, as if strong sunlight has stepped back and left finer details exposed. Surfaces that were loud a while ago become restrained. Greens can look different. Skin tones can seem quieter. The whole landscape starts behaving like it has lowered its voice. Then there are the rare little ripples called shadow bands, one of the gentlest mysteries near totality. If conditions are right, faint wavy lines of light and dark can seem to move across pale surfaces just before and just after the sun is completely covered. They are delicate and easy to miss, more whispered than shown. Scientists understand them as an effect of Earth's atmosphere bending the thin remaining sunlight in uneven ways, a little like how starlight twinkles because it passes through moving layers of air. During the late stages of an eclipse, the sun has become such a thin sliver that the atmosphere can turn that light into shimmering patterns. It is not magic. It only has excellent timing. I love that detail because it reminds you that the atmosphere is part of the experience too. An eclipse is never only about the sun and moon. Earth is involved at every step. The air filters, bends, cools, and carries the changing light. The ground absorbs less warmth. The leaves project crescents. The whole event arrives through your own planet's texture. You are not a distant observer of a cosmic alignment. You are inside the instrument that reveals it. That is why eclipses can feel so personal even though they are astronomical. The science is happening far above you, but the evidence lands on familiar things. It shows up on sidewalks, porch rails, glasses, hands, paper, water, clothing, and bark. It turns an ordinary backyard into a place where geometry and wonder briefly agree to be obvious. Keep that image nearby, because the next part of the story rests on the same idea. Tiny changes in angle and distance can transform everything you see. And the distances involved really are extraordinary. The moon is small compared with the sun, but close enough to take command of the visible scene. The sun is immense, hot beyond comfort and unimaginably far away, yet its shape can be copied by a gap between leaves and placed delicately at your feet. An eclipse makes the scale of the universe feel both grand and intimate at once. A star 150 million kilometers away is sketching crescents through a tree in your neighborhood. That is absurdly elegant. The deeper you look, the calmer it becomes. Light is not just brightness, it has direction, it has shape, it carries information. During an eclipse, the world becomes one quiet demonstration after another. A leaf gap becomes a lensless projector. A shadow edge becomes a lesson in source size. A shimmer on the ground becomes a conversation between sunlight and air. Nothing has become louder. Everything has become more revealing. Soon that revealing quality points toward one of the most astonishing coincidences in the sky, the one that makes all of this possible in such a refined and haunting way. The sun and moon, so different in size and distance, appear almost perfectly matched from where you stand. Remember these crescents on the ground and these sharpened shadows, because they are the early signs of a much deeper elegance. They are the first hint that Earth happens to sit in a place where scale can disguise itself as symmetry, and where that symmetry can turn a bright day into a moving piece of celestial design. The shape of the light itself begins to matter more and more, and that is where an eclipse quietly turns from beautiful into deeply peculiar. You are no longer only noticing that the world is dimmer. You are noticing that sunlight has changed character. It starts acting like something with edges, something with geometry, something you can almost catch in the palm of your hand if you are patient enough and standing in the right place. On an ordinary bright day, the sun looks round in the sky, and because it is a wide glowing disk rather than a single sharp point, the shadows around you usually have soft borders. A tree shadow, a hand shadow, the shadow under a chair, all of them fade a little at the edges. Light spills around objects in a generous way. The world is lit by a broad source, and broad sources make softer shadows. Your eyes are so used to that arrangement that you barely think about it. During a solar eclipse, the visible part of the sun is no longer a full round disk. It becomes a crescent, or a thinner crescent, or a narrow sliver, depending on how far the moon has moved across it. That means the source of the light has changed shape, and the shadows on the ground begin to carry that information. This is one of the calmest and most delightful facts in astronomy. The light is not only arriving, it is reporting. You can see this most clearly beneath trees. Those small gaps between leaves, the tiny spaces that usually just scatter ordinary daylight, begin to work like pinhole cameras. Each gap allows rays of sunlight through in a narrow bundle, and because light travels in straight lines, the patch of brightness formed on the ground takes on the shape of the sun at that moment. During an eclipse, that shape is a crescent. So the pavement, the grass, a wall, or even your shirt can fill with hundreds of miniature suns, all matching the one in the sky. It feels a little ridiculous the first time you notice it. You look down expecting harmless leaf shadow confetti, and instead the tree has covered the ground in astronomy. Little crescents everywhere, like the afternoon has been stamped with tiny silver smiles. The beauty of it is that nothing extra had to be added. The tree was already there. The sunlight was already there. The geometry simply became visible. This works with almost any small opening, not just leaves. A colander can do it. Crossed fingers can do it. A little hole in a piece of paper can do it. Even a gap between the edges of two objects can project the sun's changing shape. You do not need expensive equipment to meet this part of the eclipse. The world is full of accidental instruments. That is one of the sweetest things about the science here. The explanation is precise, but the experience feels generous. Nature makes the demonstration easy to join. As the sun narrows, shadows can also start looking sharper. That happens because the light source is effectively becoming smaller in one dimension. There is less broad spill, less overlap. less gentle wrapping around edges. The penumbra, the softer outer part of a shadow, can tighten. Everyday objects begin to cast shadows that look slightly cleaner, slightly stranger, as if someone quietly adjusted the focus of the afternoon. You may not even know what feels different at first. You just sense that the world has become more exact. This sharpening is subtle, and it does not always announce itself dramatically. But once you notice it, the feeling is unforgettable. It is like the day has become more careful. The bright parts are more deliberate. The dark parts are more composed. You are seeing how much the quality of light depends on the size and shape of its source, which sounds like a sentence from a physics classroom until the sky performs it so gracefully that it feels almost tender. Colors can begin to shift too, though this is more about the way your eyes and the atmosphere share the work of seeing than about the sun itself changing color. Eclipse light often feels cooler and less golden than late afternoon light. Part of that impression comes from contrast. Part comes from the fact that the overall brightness is dropping in a way that your visual system does not encounter very often in daytime. The world can seem flatter and more silvery, as if strong sunlight has stepped back and left finer details exposed. Surfaces that were loud a while ago become restrained. Greens can look different. Skin tones can seem quieter. The whole landscape starts behaving like it has lowered its voice. Then there are the rare little ripples called shadow bands, one of the gentlest mysteries near totality. If conditions are right, faint wavy lines of light and dark can seem to move across pale surfaces just before and just after the sun is completely covered. They are delicate and easy to miss, more whispered than shown. Scientists understand them as an effect of Earth's atmosphere bending the thin remaining sunlight in uneven ways, a little like how starlight twinkles because it passes through moving layers of air. During the late stages of an eclipse, the sun has become such a thin sliver that the atmosphere can turn that light into shimmering patterns. It is not magic. It only has excellent timing. I love that detail because it reminds you that the atmosphere is part of the experience too. An eclipse is never only about the sun and moon. Earth is involved at every step. The air filters, bends, cools, and carries the changing light. The ground absorbs less warmth. The leaves project crescents. The whole event arrives through your own planet's texture. You are not a distant observer of a cosmic alignment. You are inside the instrument that reveals it. That is why eclipses can feel so personal even though they are astronomical. The science is happening far above you, but the evidence lands on familiar things. It shows up on sidewalks, porch rails, glasses, hands, paper, water, clothing, and bark. It turns an ordinary backyard into a place where geometry and wonder briefly agree to be obvious. Keep that image nearby, because the next part of the story rests on the same idea. Tiny changes in angle and distance can transform everything you see. And the distances involved really are extraordinary. The moon is small compared with the sun, but close enough to take command of the visible scene. The sun is immense, hot beyond comfort, and unimaginably far away, yet its shape can be copied by a gap between leaves and placed delicately at your feet. An eclipse makes the scale of the universe feel both grand and intimate at once. A star 150 million kilometers away is sketching crescents through a tree in your neighborhood. That is absurdly elegant. The deeper you look, the calmer it becomes. Light is not just brightness. It has direction, it has shape, it carries information. During an eclipse, the world becomes one quiet demonstration after another. A leaf gap becomes a lensless projector. A shadow edge becomes a lesson in source size. A shimmer on the ground becomes a conversation between sunlight and air. Nothing has become louder. Everything has become more revealing. Soon that revealing quality points toward one of the most astonishing coincidences in the sky, the one that makes all of this possible in such a refined and haunting way. The sun and moon, so different in size and distance, appear almost perfectly matched from where you stand. Remember these crescents on the ground and these sharpened shadows, because they are the early signs of a much deeper elegance. They are the first hint that Earth happens to sit in a place where scale can disguise itself as symmetry, and where that symmetry can turn a bright day into a moving piece of celestial design. That strange symmetry is one of the quiet miracles at the heart of every solar eclipse. The sun is about 400 times wider than the moon, and it also happens to be about 400 times farther away from you. The numbers are not exact in a perfect storybook way, but they are close enough to produce one of the most beautiful visual coincidences in the sky. From Earth, the two can appear almost the same size. A star vast enough to contain more than 1,000,000 Earths can be covered by a world small enough to fit comfortably inside the sun many times over, simply because distance reshapes what your eyes receive. It is one of those facts that feels too tidy to trust at first. You hear it and instinctively assume the universe is being theatrical, but the geometry really does work out that way. The sun's apparent width in the sky and the moon's apparent width in the sky are both around half a degree, give or take a little, and that shared scale is what allows total eclipses to exist at all. If the moon looked much smaller, it would never fully cover the sun. If it looked much larger, eclipses would lose some of their delicate precision. What you get instead is a balance so exact that totality can reveal the faint outer atmosphere of the sun, while still leaving the whole event feeling graceful rather than blunt. And yet this balance is not fixed forever. That may be the most tender detail in the whole story. The moon is slowly drifting away from Earth by about 3.8 centimeters each year, roughly the pace your fingernails grow, which is such a humble speed for such a majestic consequence. This gradual retreat happens because of tides. Earth spins faster than the moon orbits, and the tidal bulges raised by the moon in Earth's oceans are pulled slightly ahead of the line between the two bodies. That offset transfers a little rotational energy from Earth to the moon, nudging the moon outward over immense stretches of time. So the perfect visual match between sun and moon is temporary, though temporary here means on the scale of millions of years, which is a very relaxed definition of the word. Long ago, the moon was closer and looked larger in the sky. Far in the future, it will appear smaller and total solar eclipses will no longer happen in the way they do today. The moon will still pass in front of the sun, but it will more often leave that bright ring around the edge. Earth is living through a special era for eclipses, and because human lives are short compared with orbital history, that era feels permanent to you even though it is really a lovely middle chapter in a much longer story. There is something deeply calming in that thought. You are not watching a cosmic trick that has always existed in exactly this form. You are living inside a window of time when the geometry happens to be especially exquisite, not by design as far as science can tell, not because the universe wanted to put on a show for your species, just because motion, gravity, and time have arranged things this way for a while. The beauty comes from the fact that nobody had to decorate it. It emerged on its own. When you think about eclipses in that wider frame, the whole event becomes even more intimate. The moon is not only crossing the sun, it is doing so at a moment in deep time when the match between their apparent sizes is almost unbelievably elegant. That is why total solar eclipses look the way they do. The moon can cover the brilliant surface of the sun closely enough to dim the sky, but not in a clumsy way. The fit is nearly exact, leaving the hidden layers of sunlight just beyond the edge waiting to appear. Keep that image nearby, because it matters very soon. There is also a subtle variation in this apparent size dance, because neither Earth's orbit around the sun, nor the moon's orbit around Earth is a perfect circle. Both are slightly stretched. That means the sun can look a little larger or smaller over the course of a year, and the moon can do the same over the course of a month. Those small changes decide whether an eclipse becomes total or annular, whether the moon reaches all the way across the sun or falls just short. Tiny differences in distance, almost laughably small compared with the scale of space, can change the mood of the whole sky. That idea is worth lingering with. So much of astronomy sounds enormous when first described, and it is enormous, but eclipses teach you that enormity is often governed by fine adjustments. A slight tilt in an orbit means most new moons pass without an eclipse. A small change in distance means a ring of fire instead of total darkness. A narrow path across Earth means one town stands in shadow while another only sees a bite taken from the sun. The universe is grand, but it works with precision. It paints with very thin brushes. And the more closely matched the apparent sizes are, the more emotionally potent the eclipse becomes. The eye loves edges. It loves clean alignments and forms that lock together with uncanny neatness. That is part of why an eclipse can feel moving in a way that goes beyond raw science facts. You are seeing two circles meet in the sky with a balance that feels almost intentional. One bright, one dark. One blazing, one silent. One unimaginably large, one modest and near. Their sizes appear equal only because your point of view on Earth happens to place them that way. Perspective becomes beauty. Perspective is doing nearly all the work here, and that is comforting in its own way. It reminds you that reality is often larger and stranger than immediate appearances suggest. The sun is not moon-sized. The moon is not sun-sized. They only seem that way because you are standing in a particular place, on a particular world, at a particular moment in history. Yet the appearance is not false. It is a real experience produced by real geometry. Truth, in this case, includes viewpoint. That is a soft and useful lesson, even beyond astronomy. It also makes you appreciate Earth more. This planet is not merely where eclipses are observed. It is the platform that makes this version of the event possible for you. A slightly different moon, a different orbital history, a different position in time, and you would inherit a different sky story. Instead, you get this one, where a receding moon still lingers close enough to veil the sun with astonishing delicacy. You get crescents under leaves, cooling air, sharpened shadows, and the promise of one of the most serene sights in nature. Because hidden behind the bright face of the sun is something that almost never reveals itself in daylight. It is there all the time, extending far into space, thin and luminous and surprisingly wild. You do not usually see it because the surface of the sun is overwhelmingly bright. But when the moon covers that surface just right, the concealed outer atmosphere can appear like a pale halo around darkness. Remember that nearly perfect match in apparent size, because it is the key that opens the next door. Without that quiet coincidence, one of the most delicate crowns in the universe would remain invisible to human eyes. That nearly perfect fit between moon and sun opens one of the loveliest doors in astronomy, because the bright face of the sun is not the whole sun. What you usually see in daylight is the photosphere, the glowing surface layer that floods your world with light. It is so bright that it hides almost everything else. The finer structures around it are simply overwhelmed. In ordinary conditions, the sun does not seem to have a soft outer veil at all. It just blazes. It keeps its subtler beauty to itself. During a total solar eclipse, for a few brief minutes, that changes. The moon covers the photosphere so cleanly that the sun's outer atmosphere, the corona, can appear around the dark center like a pale living crown. And this is where the whole event becomes even calmer and stranger than before, because the corona does not look like fire in the usual sense. It does not look like a roaring furnace, even though it belongs to the sun. It looks delicate, silvery, feathered, like light that has decided to become lace. You can understand why people who see it in person often struggle to describe it properly afterward. Photos can capture its shape, and science can explain what it is, but the feeling of it is harder to hold. You spend your life knowing the sun as something too bright to examine directly, something severe and untouchable. And then for one quiet interval, it reveals this ghostly outer presence that seems almost gentle. It is still the sun, still the same star that powers weather, oceans, forests, and your own heartbeat by very indirect but very real steps. Yet in Eclipse, it seems to have changed its voice. The corona extends far out into space, much farther than the eye can usually trace in a single glance. It is made of extremely hot, thin gas called plasma, a state of matter in which atoms have been stripped into charged particles. That may sound like a harsh and technical idea, but the image is simple enough. The corona is made of material so energized that electrons and nuclei are no longer staying together in their usual calm arrangement. It is not a solid shell. It is not smoke. It is not a neat boundary. It is a vast outer atmosphere, shaped and guided by the sun's magnetic fields. And those magnetic fields are the reason the corona has such graceful structure. It does not spread out evenly like a glowing fog around a lamp. It stretches into streamers, loops, fans, and delicate pointed forms that change over time. The sun is magnetic in a restless, intricate way. Its hot plasma moves, twists, and circulates, and those motions tangle the magnetic field into patterns that guide the corona's shape. So when you look at the corona during totality, you are not only seeing hidden sunlight, you are seeing the architecture of magnetism made visible. That is a deeply relaxing thought if you stay with it long enough. The corona looks airy and artistic, but it is also a real map of invisible forces. The universe is full of things you cannot see directly until light happens to fall on them the right way, or until brightness steps aside and leaves room for subtler truths. An eclipse is one of those rare moments when overwhelming light becomes selective light, and the hidden design of a star suddenly drifts into view. There is a detail here that feels almost impolite in how surprising it is. The corona is much hotter than the visible surface below it. The photosphere, the layer you think of as the sun's surface, is already incredibly hot, around 5,500 degrees Celsius. But the corona reaches temperatures of more than 1,000,000 degrees. That sounds backwards, because in most ordinary situations, moving away from a hot object means things get cooler. Near the sun, the outer atmosphere can be far hotter than the layer beneath it, which is one of those facts that quietly reminds you the universe does not owe your intuition an easy time. Scientists have worked hard to understand this puzzle, and while there is still active research into the details, the broad picture points again to magnetism. Energy from the sun's magnetic fields appears to be transferred into the corona in ways that heat the plasma enormously. Waves moving through magnetic structures may help. Tiny magnetic reconnection events, where field lines snap and realign, may help too. The exact balance is still being explored, which gives the sun a little room to keep its dignity and mystery. It has explained a lot over the centuries, but not everything. Even that uncertainty can feel soothing when it is held the right way. Not all mysteries are frightening. Some are simply spacious. The corona is one of them. You can know what it is in broad terms, understand why it becomes visible during totality, learn how magnetic fields shape it, and still leave a small chamber open in the mind for wonder. Science does not ruin the beauty here. It gives the beauty texture. The light of the corona is faint compared with the photosphere, which is why it disappears from view the moment the sun's bright surface is exposed again. The ordinary sun is so intense that the corona is washed out completely. Only during totality, when the moon covers the brilliant central disk, Does the contrast become gentle enough for your eyes to notice that glowing outer atmosphere? That means one of the most elegant features of your nearest star is present every day and hidden every day, quietly waiting behind brightness. There is something tender in that. Some of the most beautiful things in nature are not absent, they are merely outshone. If you were standing under totality, another feature might appear for just an instant before or after the corona fully opens. Bright points of sunlight shining through valleys along the moon's rugged edge. These are called Bailey's beads, and they give the impression that the sun is breaking into tiny jewels at the border of darkness. For a moment, the eclipse becomes even more delicate, the light fractured into beads by the topography of the moon itself. Mountains and craters on an airless world shape the last visible rays of a star. It is such an absurdly elegant sentence that it almost sounds ornamental, but it is simply true. And then, when the photosphere is fully hidden, the corona takes over the sky's emotional tone. It is not bright like noon. It is not warm like sunset. It is something rarer. A cool radiance around a dark circle, soft enough that planets or brighter stars may appear nearby if the sky is clear enough. The day has not become night in the ordinary sense. It has become a different category of day altogether, a suspended light, an in-between light, a light that feels borrowed from some calmer version of the universe. The corona also matters far beyond beauty. It is linked to the solar wind, the stream of charged particles flowing outward from the sun through the solar system. That wind shapes space weather, interacts with magnetic fields, and helps produce auroras when conditions are right around planets like Earth. So this faint halo is not some decorative fringe. It is part of the sun's ongoing conversation with the worlds around it. What looks like a delicate crown is also an active reaching outward. Keep that image nearby. The pale corona expanding into space, the magnetic field drawing its lines through invisible force, the sun not ending cleanly at its bright surface but continuing in a thinner, hotter, stranger way. Because once the light changes enough for you to notice the corona, Earth notices other things too. Air cools further. Winds can shift. Creatures pause. The whole local world responds, not dramatically, not noisily, but with small adjustments that make the eclipse feel even more complete. The sky changes first, and then the planet answers. The planet answers in its own soft language. Once the sun's light begins to fade enough, Earth does not stay entirely unchanged beneath it. The ground starts giving back a little less warmth. The air above that ground notices. A field notices. A lake notices. The leaves of trees notice. Even your own skin can notice, because an eclipse is not only something seen with the eyes. It moves through temperature, texture, sound, and timing. It slips into the ordinary systems of the day and asks them, very politely, to behave a little differently for a while. One of the first responses is cooling. Sunlight reaches the ground absorbs that energy, and then the ground releases warmth into the air. That cycle is happening around you every bright day, whether you think about it or not. During an eclipse, part of that incoming energy is reduced. The sunlight weakens. The surface heating eases. The air near the ground can begin to cool by a few degrees. Sometimes the change is modest. Sometimes it is more noticeable. It depends on clouds, humidity, landscape, season, and how much of the sun is covered. But the principle stays beautifully simple. A dimmer sun makes a gentler afternoon. And the gentleness can feel surprisingly immediate. You may not measure it first with an instrument. You may simply sense that the warmth on your arms has softened, or that the breeze feels less sunlit than it did half an hour earlier. That is one of the lovely things about eclipse science. You are not dealing only with distant abstractions. The alignment above you reaches down into the air and touches the body. It makes astronomy feel local. Because warm air behaves differently from cooler air, Even small temperature changes can begin to reshape the movement of the atmosphere near the ground. On a normal sunny day, sunlight drives little rising motions of warm air from the surface. During an eclipse, that heating weakens, and some of those motions can calm down. Winds may shift slightly. In certain places, people describe an eclipse wind, a feeling that the air briefly reorganizes itself as the light fades. Scientists treat that idea carefully because the exact effect varies and can be subtle, but there is real atmospheric physics behind the reports. When you change the heating, you change the small balances that help shape local air movement. I like that the air does not panic, it simply adjusts. The atmosphere is very good at adjustment. It has been handling sunlight, darkness, cooling, warming, pressure, and motion for a very long time. An eclipse is unusual in timing, but not impossible for physics. So the day becomes cooler, a little calmer, a little more layered, and sometimes the whole landscape feels as if it has taken one quiet inward breath. Then there is the matter of sound, which many people remember as vividly as the changing light. Creatures that use daylight as a cue can begin to alter their behavior. Birds sometimes grow quieter or head toward roosting habits associated with evening. Diurnal insects may slow their activity. Nocturnal ones occasionally stir in confusion or curiosity if the darkness becomes deep enough. Farm animals have been observed changing position or settling down. None of this happens according to a perfect script. Living things are wonderfully inconsistent, but the general pattern makes sense. Many organisms do not need a telescope to care about the sun. They already treat light as a clock. That clock is suddenly behaving in a very unusual way. The brightness falls, but not on the normal schedule. It feels like late day without the hours that usually lead there. It is as if Earth briefly skips ahead in mood while keeping the same page of the afternoon open. For animals and plants tuned to rhythm, that can be enough to provoke a response. Blossoms that react to light may partially close. Birds may reduce song. Cicadas may change their pace. The world does not hold a conference about it. It just leans into instinct. The human response is quieter too, though in a different way. People often become hushed during the deepest stages of an eclipse, and I do not think that is only because they are concentrating. There is something about the altered light that encourages softness. The usual confidence of daytime has been gently interrupted. Your surroundings are familiar, yet somehow provisional. A parking lot, a rooftop, a field, a neighborhood sidewalk can suddenly feel ceremonial without becoming theatrical. Even places with no natural grandeur can gain a strange dignity under eclipse light. The sky lends them one. Part of that feeling comes from contrast. You are used to daylight meaning clarity, activity, definition. During an eclipse, daylight remains visible, but the emotional texture changes. Colors mute a little, shadows behave differently, temperature shifts, sound may thin out. Your brain, which is very skilled at matching sensory inputs to expected patterns, realizes the pattern is off by just enough to feel important. Not dangerous, not necessarily, just important. The world is still itself, only more watchful. Lakes and rivers can join this change in subtler ways. Water responds more slowly to temperature change than land does, so a short eclipse does not transform a lake dramatically, but the surfaces of water can still reflect the altered sky in a different tone. The light on them may look cooler and more metallic. A calm pond under eclipse light can seem to belong to a different hour entirely. Even stone can look changed. Roads and walls lose some of their daytime glare. Trees seem more precisely shaped. Open spaces feel larger, perhaps because the sky itself has become harder to classify. It is also worth remembering that the shadow passing over Earth is an actual moving region of reduced sunlight. That sounds obvious, but it carries a strange comfort when you picture it properly. A patch of shadow cast by the moon is gliding over oceans, forests, towns, mountains, farms, and coastlines. It is touching one place, then another, changing each one briefly before moving on. Somewhere the air cools, somewhere birds settle, somewhere a child notices crescent shadows under a tree. Somewhere the corona opens above a silent crowd. The same event is meeting many versions of Earth at once. This gives eclipses a kind of planetary tenderness. They are grand enough to involve celestial mechanics, solar atmospheres, magnetic fields, and orbital distance, yet specific enough to pass over one hillside, one river bend, one village square. The cosmic and the local fit together perfectly for a while. A star, a moon, a planet, and the daily lives of creatures all become part of the same quiet composition. And because Earth is rotating, orbiting, breathing weather, carrying oceans, and supporting life all at once, every eclipse becomes a collaboration between the sky and the world below it. The sun provides the light. The moon reshapes it. Earth receives it, cools under it, reflects it, and responds through air and living things. Nothing is isolated. That may be one of the calmest truths in the whole journey. Even something as celestial as an eclipse becomes real through relationship. Keep that idea nearby, this sense of Earth as an active participant rather than a passive stage, because the story widens again from here. Human beings have always stood inside these changes and tried to explain them, comfort each other through them, celebrate them, and remember them. Long before the geometry was fully understood, people still felt the cooling air, saw the altered light, heard the sudden hush in birds, and knew they were inside a moment unlike ordinary day. The science came later in clearer form. The feeling arrived first. By the time you have followed the moon across the sun, watched shadows sharpen, seen the hidden halo waiting behind daylight, and felt Earth itself cool and quiet under the passing shadow, it becomes very easy to understand why human beings have always treated eclipses as more than ordinary sky events. Even before anyone could explain the orbital mechanics, people could feel that something unusual had entered the day. The air changed. The light changed. Birds shifted. Time itself seemed to wobble a little. And because human beings are meaning-making creatures, wonderfully restless ones, they did what people have always done under a strange sky. They told stories. They watched more carefully the next time. They remembered. Some of the oldest eclipse traditions come from ancient China, where solar eclipses were sometimes described as the sun being eaten, often by a dragon or monstrous being. Over time, Chinese observers also became some of the world's most careful record keepers of eclipses. Britannica notes that Chinese chronology can be anchored by eclipse records from the 8th century BCE onward, and that the Chungkyu Chronicle preserves the earliest surviving series of solar eclipse observations anywhere in the world, covering 36 eclipses between 722 and 481 BCE. It is such a lovely pairing of instinct and discipline. A sky once imagined through myth also studied with increasing care, until fear and observation began sharing the same page. You can almost picture those early observers under a dimming sky, not as cartoons of superstition, but as people trying honestly to live inside a world that still kept many of its mechanisms hidden. The sun was not merely a bright object to them. It was rhythm, order, harvest, time, kingship, season, blessing. When it darkened in the middle of the day, the emotional weight would have been enormous. A farmer, a priest, a ruler, a child standing in a courtyard, all of them would have felt the same interruption first through the body. Light fading, air cooling, a hush moving through birds and people alike. You do not need to mock ancient explanations to understand them. The event itself already contains enough mystery to deserve reverence. Elsewhere in Mesopotamia, eclipse watching became something even more quietly remarkable. Babylonian astronomers recorded eclipses with enough care that their observations still matter to science now. Britannica preserves a striking description of a total solar eclipse observed at Babylon in 136 BCE, including the time after sunrise, the duration, the onset of totality, and the visibility of stars and planets during the darkness. Modern analysis of records like these, along with other historical eclipse accounts, helps scientists trace long-term changes in Earth's rotation. In other words, people who looked up thousands of years ago are still helping you understand the timing of the planet beneath your feet. That may be one of the calmest facts in all of astronomy. Old wonder can become precise knowledge without losing any of its beauty. The Babylonians also learned that eclipses were not random visitors. Patterns could be found. Cycles could be noticed. The sky, while dramatic, was not chaotic. It repeated itself with enough fidelity that human memory, and then written memory, could begin to anticipate its moods. That transition matters. Once you learn that an eclipse belongs to a rhythm, the universe becomes less like a place of sudden punishment and more like a place of deep recurrence. The shadow still feels powerful, but it is no longer untethered from reason. It joins a pattern. It takes its place in a sequence. That may be one reason eclipses sit so beautifully at the border between myth and science. They do not flatten human imagination. They invite it, then gently refine it. A dragon becomes a node and an orbit. An omen becomes a data point. A gasp becomes a calculation. Yet none of that removes the emotional truth of the experience. Even when you know exactly why the eclipse is happening, you still feel the old hush arriving. Knowledge does not erase wonder here. It gives it a deeper foundation. You can find that same human response in ancient Greek writing too. Smithsonian notes that when a solar eclipse darkened the sky over Paros in the 7th century BCE, the poet Archilochus responded with lines of astonishment, as though the ordinary rules of the world had loosened. That feels so familiar. A poet on an island long ago, looking up at a darkened sun and trying to put the feeling into words. A person in the present doing exactly the same thing in a quieter, more scientific vocabulary. The centuries pass, the explanations sharpen, and still the sky can leave language slightly behind. And this is where the emotional history of eclipses becomes unexpectedly comforting. Across continents and centuries, people kept looking up. They did not stop because the event was strange. They looked more carefully because it was strange. Ancient Americans carved sky images into stone. Chinese scribes wrote eclipse dates into chronicles. Babylonian observers timed darkness against sunrise. Medieval astronomers compared eclipse observations with stars and horizons. Modern scientists later used many of those records to study changes in Earth's rotation, because the timing of the shadow carries information not only about the sky, but about the spinning of the Earth itself. A day dimmed by the moon can whisper to later centuries about milliseconds, centuries, and planetary timekeeping. It is hard not to love that. A brief darkness in one age becomes a clue in another. The same event that once made people gather in uncertainty now helps researchers measure how the length of the day has changed over millennia. NASA explains that hundreds of historical eclipse and occultation records from Chinese, Middle Eastern, and European sources are among the only evidence we have for tracking the value of delta T, the growing difference between uniform time and Earth's not quite uniform rotation, across the distant past. The shadow passes. The record remains. Time itself leaves fingerprints in the memory of an eclipse. And maybe that is the most peaceful thread running through all of this history. Eclipses have always brought people to the edge of what they know, but they have also gently expanded that edge. They asked early observers to pay attention. They taught later observers to compare records. They taught astronomers that the heavens repeat with rhythm. They taught historians that careful notes can outlive empires. They taught modern scientists that the old world was watching more closely than people sometimes assume. Under a darkened sun, human beings were already doing one of their finest things. They were looking, keeping track, and trying to understand with the tools they had. That long continuity makes the next widening feel almost inevitable. Once people began to recognize that eclipses belong to patterns, the shadow stopped being only a visitation and became part of a larger celestial order. The local drama of a dim afternoon opened into something much broader. Earth was not the only place with shadows. The moon was not the only moon. The sun was not the only star whose light could be crossed, interrupted, or briefly transformed. Keep that old human gaze nearby, the one that began with wonder and matured into careful watching, because the story is about to leave Earth for a while and discover that eclipses are not just part of your history. They are part of the universe's style. That feeling of old human wonder does not stay on Earth for long. Once you begin to see eclipses as part of a wider celestial rhythm, the mind naturally drifts outward. You realize the moon is not the only moon casting shadows. Earth is not the only world that lives under them. The same quiet geometry appears again and again across the solar system, changing its mood to suit each place, as if the universe enjoys repeating one elegant idea in different accents. On Mars, for example, eclipses are quicker, leaner, and a little more fragile than the ones you know here. NASA's Perseverance rover has filmed Phobos crossing the Sun from the Martian surface, and the sight is almost startling in its speed. Phobos is a small, irregular moon, so it does not draw a long, dark curtain across the sky the way Earth's moon can. It skims across the Sun in a brief transit, more like a hurried passing mark than a lingering cover, and the shadow it casts on Mars is small and diffuse. Deimos, the more distant and smaller Martian moon, makes an even gentler passage, a tiny silhouette moving across sunlight in a way scientists describe as a transit rather than a full eclipse. There is something unexpectedly calming about that difference. On Earth, an eclipse can feel ceremonial, slow enough for the light to cool and the atmosphere to gather itself. On Mars, the same idea becomes brisk and spare. The Sun itself also looks smaller there than it does from Earth, because Mars is farther away, so the whole event feels scaled down, as though the sky is demonstrating the same principle with a finer pen. You still get alignment, shadow, and motion. You still get the unmistakable truth that one world can pass in front of a star from the viewpoint of another. The universe keeps the structure and changes the texture. Around Jupiter, the story becomes busier and somehow even more graceful. Jupiter has a vast family of moons, and when the geometry is right, those moons do not only cast shadows on Jupiter. They can eclipse one another, transit one another, and create what astronomers call mutual events. NASA has described seasons when the Sun crosses Jupiter's equatorial plane, and the Galilean moons begin performing these intricate alignments in sequence. It is a lovely image to hold for a moment. Far from Earth, around a giant striped planet, whole moons are slipping through one another's light, making eclipse after eclipse in a system large enough to feel orchestral. The same quiet mechanics are there, only multiplied. Pluto and Charon offer an even stranger kind of intimacy. Charon is so large relative to Pluto that the two do not behave like a simple planet and tiny moon pair. They orbit a common center of mass, and they are tidally locked, turning in such a way that each keeps the same face toward the other. NASA notes that from Pluto's surface, Charon would remain in the same part of the sky relative to the local horizon, which already feels dreamlike enough. And when Earth happened to line up close to the plane of their orbit between 1985 and 1990, astronomers were able to observe a series of Pluto-Charon mutual eclipse events from ground-based observatories. That means there was a season when two frozen worlds at the edge of the solar system were taking turns dimming each other's light in a rhythm patient enough to be measured from here. Once you notice these repeating patterns, eclipses stop feeling like a local treasure and start feeling like part of the universe's handwriting. A moon crosses a sunlit disk on Mars. Jovian moons slide through each other's shadows. Pluto and Charon trade eclipses in their cold, slow dance. And beyond the solar system, the same geometry becomes one of the main ways astronomers find planets around other stars. NASA explains that a transit happens when a planet passes between its star and the observer, causing a slight dimming of the starlight, and most known exoplanets have been discovered through that method. So even when you cannot see a distant eclipse directly with your own eyes, the universe is still writing it into the light. A tiny, repeated softening of a star can announce the existence of a world you will never visit, orbiting in darkness around a sun you will never touch. That may be one of the most beautiful facts in the whole subject. An eclipse is not only something dramatic that happens above a field on Earth while birds go quiet and the air cools around your shoulders. It is also a method, a clue, a signature. It is a way for distant systems to introduce themselves. A planet can say, very softly, "I am here," by passing in front of its star again and again with patient regularity. And that patience matters. These events are not random flashes. They belong to orbit, repetition, timing, and the long obedience of gravity. The farther outward you look, the more the whole cosmos begins to feel less like scattered objects and more like a set of relationships written in motion. So the shadow that once felt like a rare gift of your own sky turns out to be part of a much larger calm. Eclipses happen in quick strokes on Mars, in layered performances around Jupiter, in frozen mutual seasons near Pluto, and in the faint dimming of stars light years away. The forms change, the scales change, the pace changes, but the underlying beauty remains strangely consistent. One body crosses another. Light softens. Hidden structure appears. A rhythm reveals itself. Keep that feeling nearby, because the next thing waiting inside it is even quieter. The deep patience behind all these crossings, the slow orbital trust that lets them happen at all, and the almost impossible steadiness with which the universe keeps time. By the time the shadow has carried you this far, the most soothing thing about eclipses may no longer be the darkness itself, or the crescent light under leaves, or even the pale halo of the corona. It may be the patience behind it all. An eclipse only happens because nothing in this system hurries. The moon keeps its orbit. Earth keeps turning. The sun keeps shining with that enormous calm that stars seem to possess almost by instinct. And every so often, after all that steady motion, the geometry folds into place and gives you a moment that feels rare only because the rhythm beneath it is so dependable. That patience shows up first in the simple fact that eclipses belong to cycles. One of the most famous is the Saros, a period of about 6,585.3 days, or roughly 18 years, 11 days and 8 hours, after which the Sun, Earth, and Moon return to very similar geometry. That is why eclipses can seem to echo across generations. They are not identical twins, because the extra 8 hours means Earth has turned farther, shifting where the next eclipse is visible, but they are close relatives, repeating the same deep arrangement with a slightly different view. The sky does not repeat itself mechanically like a machine with no imagination. It repeats like music, with structure and variation at once. And the Saros itself exists because several lunar rhythms almost line up with extraordinary elegance. The cycle comes from a near harmony between the synodic month, which carries the moon from one new moon to the next, the draconic month, which measures the time between passages through the orbital nodes, and the anomalistic month, which tracks the changing distance of the moon in its elliptical orbit. Those different clocks are not perfectly identical, but they come close enough that eclipses return in families, as if celestial motion has learned how to rhyme over very long lines. That is one of the softest and strangest truths in astronomy. Different kinds of motion can stay distinct and still agree beautifully from time to time. The moon's own behavior is full of that same long patience. It rotates once for each orbit around Earth, which is why the same side faces you most of the time, a state created by tidal locking. NASA explains that this happened because energy was dissipated over time until the moon's spin slowed and matched its orbital period. The process did not happen in a dramatic burst. It happened gradually, through the quiet accounting of gravity and friction, until the moon settled into the familiar relationship you know today. The face you see in the sky is the result of a very old calming down. And the calming is still not finished. The moon continues to drift away from Earth at about 3.8 to 4 centimeters per year, powered mainly by tidal interactions with Earth's oceans. Those ocean bulges do not sit exactly under the moon. They are pulled a little ahead by Earth's rotation, and that offset helps slow Earth's spin while nudging the moon outward into a slightly larger orbit. The pace is tiny, almost comically tiny, about the growth rate of fingernails, but over millions of years it becomes enough to reshape the future of eclipses themselves. That is such a gentle kind of grandeur, a fingernail pace changing the architecture of the sky. Earth answers by turning a little more slowly across deep time. NASA's tidal research explains that tidal friction produces an extremely slow secular change in Earth's rotation, increasing the length of day by about 2.3 milliseconds per century, while JPL notes that the mean solar day is now slightly longer than 86,400 atomic seconds because Earth's rotation is gradually slowing. It is a small effect in human terms, easy to ignore over a lifetime, but it matters over centuries and millennia. The days of Earth are not fixed in stone. They stretch, almost politely, as gravity continues its long conversation with ocean and moonlight. That long slowing is one reason eclipses feel so ancient and so alive at the same time. They are not frozen artifacts. They are moving products of a changing system. The moon was once closer. In the distant future, it will be farther away. NASA notes that the present near match between the apparent sizes of the sun and moon will not last forever, and that once the moon has receded enough, it will appear too small from Earth to cover the sun completely. Total solar eclipses belong to a chapter in Earth's history, not to all of history equally. You happen to live in a window when the geometry is especially beautiful. That should feel less like pressure and more like gratitude. Even the shifting path of one Saros eclipse to the next carries that sense of patient motion. Because the cycle includes an extra third of a day, Earth rotates about 120 degrees farther before the next related eclipse arrives, moving the shadow westward to a different part of the globe. 3 Saros cycles, a little over 54 years, bring the geometry back toward a similar region again. So an eclipse family can spend centuries climbing gradually from polar regions toward the equator and then on toward the opposite pole before fading away. A single series can live for more than 1,000 years. That is not the tempo of urgency. That is the tempo of continents, ice sheets, languages, and old trees. There is comfort in realizing that nothing about an eclipse is improvised. The beauty feels sudden only from the scale of a human afternoon. From the scale of celestial motion, it has been approaching with extraordinary patience for years, decades, centuries, and longer. The new moon had to arrive. The node had to be nearby. The distances had to cooperate. Earth had to turn the right place under the shadow. Even the air that cools beneath it and the leaves that project crescents are part of a chain of causes so smooth that it can feel almost intimate. The universe is not rushing toward spectacle. It is simply being faithful to motion. And perhaps that is why eclipses calm you so deeply when you linger with them. They remind you that magnificence does not require speed. Some of the most moving events in nature are built from repetition, restraint, and long obedience to invisible laws. Gravity does not get tired. Orbits do not become impatient. Tides keep working their small changes into water and time. The moon keeps easing away. Earth keeps giving up a little of its spin. And from that vast, unhurried process comes a shadow that crosses a field, cools the air, reveals a hidden halo, and then passes on, leaving the day brighter but the mind somehow quieter. Keep that quiet nearby, because only one step remains. The light is about to return fully, and with it comes the final tenderness of the whole journey. The feeling that after all this grandeur, the universe is still gentle enough to hand the sky back softly.